In this video, we will try to understand the major evolutionary milestones in the development of a big data management system. The notion of big data took shape in the form of the enormous amount of data generated from various data sources that accumulate data from various enterprise applications. This was the first iteration of a big data management system that took shape during the 1980s and 1990s. The key component of this iteration was the data warehouse. Using a simple query-based analytics engine, the data was pulled from the data sources to the data warehouse. It was then transformed within the data warehouse, and then queried from the business intelligence applications to generate dashboards, reports, and visualizations. The first iteration was capable of independently processing the data for extracting business insights, but it was not efficient in handling a really big volume of data. Therefore, the second iteration of Big Data Management System introduced the data lake. The data lake acted as a central repository for the raw data ingested from the various data sources. In addition to that, the analytics engine also acted upon the data lake to transform the data into a pre-processed form, and load it into the data warehouse. The link between the data warehouse and business intelligence systems was intact as in the case of the first iteration. However, there was a significant improvement in data handling capacity. The next iteration combined the power of the data lake and data warehouse into one. The result was a data lakehouse. A data lakehouse enables more efficient and seamless processing of data within a big data management system. That's because it avoids many temporary loading and staging operations performed between separate data lake and data warehouse instances in the previous iterations. By transitioning to a cloud deployment, the data lakehouse and the analytics engine got elevated to the next iteration, which is capable of handling a massive volume of data at a very high velocity, signifying the real attributes of big data. This is where a big data management system takes a leap from centralized storage and processing of data, to a decentralized approach. With the approach, multiple instances of analytics engines and data lakehouses are provisioned to manage different datasets. This marks the emergence of big data mesh. These datasets are divided into different domains which are segregated based on organizational functions, or business units. Depending upon the organizational requirements, multiple such domains can crop up. Each domain team is responsible for managing its big data workflow, in a completely independent infrastructure. However, they cooperate in a federated arrangement to offer their data as a product to each other, which is ultimately consumed by the business intelligence applications.